So in Zone A 2011 paper, we need to derive the economy's balanced growth path analytically and show in a diagram how the steady state levels of capital and output per efficiency unit of labor are determined. So we need to find the growth rates of output and output per worker. The derivation of the balanced growth path should be found in the notes given to you during your course. So we first have our production function, which is y equals to a function of capital, technology, and labor. So to convert them to efficiency units, we just have to divide by AL, which will give us function of K, small k in this case. Because it is the constant return to scale, it allows us to divide it equally to get 1 and subsequently a small k. So the growth rate of k, the small k, can be shown in this diagram, where it's a dot over the small k divided by k. As you can see, growth rate is derived from the equation. So if we have a divide, which means it is a minus, and we have a multiply, which is between A and L, it will be a plus. But in this case, we have K minus A plus L, which is K minus A minus L. Remember, this is only for K dot over K. It also applies to A and L, but it has to be in this form. So moving on, we know that growth rates of technology and labor is given by G and N. So by substituting it in, and with a constant depreciation rate of delta, the change in K, which is our capital stock, is equal to whatever you invest minus the depreciation of capital which you have in the previous period. So this is a change in our capital stock. So as you know, savings is a part of your income. So it could be denoted as a small s, which is our saving rate, multiplied by our income, which is our output in this case. Now if we were to put all the equations together, we will get this form here. So what does this form means? So from the first step to the second step, all we need to do is just to split them up and then divide them to convert them into small y and small k. And the next step, we have a small y, we can change it to a function of k. Subsequently, we know that on a balanced growth path, savings must be equal to depreciation. Savings in this case is called the amount of capital, additional capital that we put into our capital stock. And then we will get a steady state level of k. So this k doesn't change in any long run time. So moving on, from first equation to the second equation, all we need to do is to rearrange them. So by moving A and L over to the other side and then changing them to the constants, we could get this function here. How did we get to this function? Remember that on a balanced growth path, since the change in k, small k, is 0, and y equals to a function of k, it has to be that since k is not moving or growing, y has to be constant as well. So the growth rate of y is 0. The change in output is 0. So we get to change in output or growth rate of output without the efficiency unit of labor is equals to the growth rate of labor and the growth rate of technology. And remember that per worker output is denoted.
Thanks for watching a sample of the Quickienomics online learning experience. We hope you've enjoyed it. We believe that true happiness lies in realizing ambitions and dreams. That's why we make our products specific to your needs, simple to understand and captivating, so that you can learn effectively while saving time, realizing those ambitions and dreams. The Quickienomics online learning experience is a range of supplementary lectures, tutorials, and exam solutions in the form of videos which you can conveniently view anytime, anywhere. Watching our videos before and after your regular lessons at school, we aim to give you joy in learning and build academic confidence at the comfort of your own relaxed learning environment. So how can you begin? We welcome you to purchase Quickie to redeem the videos for full access to the Quickienomics online learning experience. Thank you for starting with Quickienomics.